Okay, so we started recording. So Avogadro's value constant refers to the number of. No, it's not the number of moles. Yes, correct. It's the number of molecules in 1 mole. Number molecules in 1 mole. Okay, so this is a constant. Okay, very good. See a lot of replies there. And where we use Avogadro's constant is in this lovely equation. Okay, so Avogadro's constant tells us the number of molecules in 1 mole, but if you are given a setup, in order to find the number of molecules, we first need to find how many moles that setup contains, right? And to find that, we use this lovely equation over here. Now, this equation is only true for ideal gas, but I think, yeah, just be aware of the assumption, okay? Yeah. Yeah, so just remember that the units for this must be considered. So this one is in Newton per meter square. This one is in meter cube. This one is a constant at 8.31. Sorry, this one is a constant 8.31. This is your variable, and this one is in Kelvin. Okay, so just bear in mind the units when you do this, use this formula. Okay, now that we are here, I think I have one question, example question to reinforce these topics. Okay, let me clear all this. Dun, dun, dun. Then we can talk about ideal gas. So this was one of the questions sent in Telegram. I hope the person who sent it in Telegram is here so that if he or she has any problems, you can ask immediately. Okay, yeah, so this one, let's do this one. The lowest pressure, this is question 2. The lowest pressure attainable using the best available vacuum technology is about 10⁻⁻12 Newton per meter squared at 2 degrees Celsius. Then they ask you, at such a pressure, how many molecules are there per cm3? Okay, so at this point, if you haven't had a chance, I'm going to give you a minute or so to try and solve this. I'll just outline the steps that you think can give you the answer. Yes, correct. N in nRT is the number of moles. So yeah, just a hint, you need to use this because we talked about it, and you also need to recall Avogadro's constant. Do we assume the volume is 1? Later we'll get to it. Okay, okay, maybe we can walk through the question now. Okay, yeah. So, oh, what did I click? Okay, so when we look at this formula, we know that this setup has a pressure of 10⁻⁻12, right? So it's like 10⁻⁻12 multiplied by volume. Volume is equals to the number of moles that we're trying to find. Then the rest is given at 8.31 times 273 plus 2 is 275. 75 Kelvin. Then they ask you how many moles are there per cm3? Per cm3. So in order to find the number of moles per cm3, can we let this be 1? Recall that in our original formula, the units of volume is meter cube. So if we want to find the number of moles per cm3, we need to find, we need to let this be 1 over 1000. Does this make sense? Because 1000 cm3 is equals to 1 meter cube. So if you let this be 1, you'll get the number of moles per meter cube. If you let this be, oh sorry, not 1 over 1000. If you let this be 1000, you get the number of moles per cm3. Okay, everyone okay? Everyone know where I'm coming from? Maybe I give you a bit of time if you have any questions. Okay, all good. So we just let this be 1000, we can find the number of moles per cm3. Then, of course, we just sub in the numbers. 1000 times 10 power minus 12 divided by 8.31 times 275. So this will give us the number of moles per cm cube. And of course, we know that 1 mole is going to have 6.02 times 10 to the power 23 molecules, right? This is constant no matter what gas it is. Molecules per mole. So we just need to take this number of moles per cm cube multiplied by number of molecules per mole. We will get the number of molecules in the cm cube. Okay, are we good? Any questions?
I got a question.
Yeah, what's that?
So for this question, right, do we still take the volume as 1 meter cube?
Okay, you can leave it as 1 meter cube, but then you need to be very careful for your units.
Because they didn't provide us the volume, that's why.
Yeah, that's okay, because they ask you this number of molecules per unit volume, right? Per cm cube is per unit volume, right? So if we assume it's 1, PV is equals to nRT. If we assume that this is 1, our number of moles over here is going to be number of moles per meter cube. Correct?
Oh, okay, get it.
Okay, nice.
Thank you.
No problem. So in case the rest don't understand, just to continue. If you let this be 1, it's number of moles per cm per meter cube. If you let this be 1000, we are going to get the number of moles per cm cube. Because 1000 cm is 1 meter cube. 1000 cm cube is 1 meter cube. Okay? Okay, nice. Okay, so let's move on. And yeah, I think since we're at this image, we can also do question 1. Just as a quick brain exercise. Okay, so we can look at this. I'm gonna give you 30 seconds because this should be fairly easy. Okay, yeah, so let's run through the question. It says a leaky tap drips a drop of water every second, and at this rate, so 1 drop of water every second, it takes 1 hour to fill 200 cm cube. Then it asks you to determine the average volume of the drop. So we know that in 1 hour, how many seconds do we have? We have 60 minutes, and each minute has 60 seconds, right? So 3600 seconds per hour, which means that there's 3600 drops after 1 hour. So 3600 drops gives us 200 cm cube. Then of course we can find what is the volume of each drop. Divide both sides by 3600. Okay, so it sounds fairly self-explanatory. Yeah, don't be confused by the irrelevant details like this nonsense over here. Just cross it out. Okay, so I hope that's not too difficult. Yeah, let's go back to the summary. Okay, so we have covered the gas law, covered Archimedes principle, covered pressure. The next sub point we need to know is regarding heat. And this one we need to first know familiar with this equation. 1 plus thermal expansion coefficient times temperature change. So just a quick verbal recap. This means that the new length is equal to the original length multiplied by 1 plus the linear thermal coefficient, multiplied by the change in temperature. Okay, so this change in temperature, does it matter if it's Kelvin or degrees Celsius? No, it doesn't matter, because each of these increments, the difference, is going to be the same magnitude. So the raw value is going to be different. So 2 degrees Celsius is 275 Kelvin. So they're not the same. But if I tell you increase in 2 degrees Celsius, it's going to be also the same as increase in 2 Kelvin. Okay, so just a gentle reminder. Yeah, back to this. So this is for one-dimensional expansion. So we have a beam and then we expand it like that. For 3D, we have a small cube, we hit it, we become a big cube. the formula is very similar. The only difference is that it's volume instead of length, and this is a volumetric thermal coefficient. Yeah, and for a lot of materials, this is just 3 times the linear one. Okay, so other than this, the last equation, I think, for the first part that we need to know is the heat transfer energy equation, C delta T. So this basically states that a change in energy, so this is in joules, is equals to the mass of the object in grams. This is joule per gram, joule, gram, Kelvin. And this is Kelvin or degrees Celsius. Okay, so let's say I add in 100 joule into the object. I can find the corresponding change in temperature. Okay, so this one is quite easy. I hope none of you are seeing these equations for the first time. Okay, next one, kinematic basics. Let's go to a new slide.
Sorry, can I ask a question?
Yeah, what's up?
Sorry, there's like this usually this kind of questions where like they're asking like if the temperature is increased by 1 degrees, the volume changes. Then they ask you what kind of temperature would the volume of water change by twice as much when increased by 1 degrees. What does that mean by the question?
Can you send the question to the Telegram?
All right.
Thank you. Okay, let's look. Yeah, maybe while waiting for you to say, oh, you sent it already.
B. January, yeah.
Okay, can. Okay, let's take a look at that. Can you send a upright photo?
Oh, okay.
And got clearer one. Okay, that one. Okay, clear enough.
Sure.
Now we prepare the next slide for kinematics.
Yep.
Okay, thank you. So let's look at that. Okay, let's copy this and take a look at it together. Oof. Side. B. Okay, let me crop. Then we can zoom in. Okay, sorry, I'm quite blind. I need to make super big. Okay, so let's look at the question together. The anomalous expansion characteristics of liquid water are crucial to blah 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 blah. Rather than approximately constant value for the coefficient thermal increases drastically. Sure. So this volume expansion coefficient. Okay, so I would first thing bear in mind this this graph is in 10 to the power minus 4. This, okay. The next one is temperature over here. So they give you the different values of this at different temperature, right? Okay, then they say that the volume of water in the 4 degree is measured to be V4. Experiment is conducted. Study how the volume of water changes with temperature. Change from 4 to 5. This one is 4 to 3. 0. The temperature of water at 1 degrees is raised by 1 degree C. Volume changes at approximately 1 initial temperature, where the volume of change by twice as much is raised by 1 degree C. Okay. So this is an interesting question because earlier we discussed the formula. We assume that the volumetric thermal expansion coefficient as well as the linear one are constants, right? In this case, they're telling you that, hey, for water in this temperature range is not going to be a constant. So they ask you to use the value of this graph in order to know how much it changes when it gives a change in temperature. Okay, so this looks like a final paper. Okay, never mind. Yeah, so we know that. Okay, let's do A part 1 and part 2, just for completeness sake. We know that from 4 to 5 degree, right? We look at here, 4 to 5 degree. The volume of sorry, the volume expansion coefficient is what? Is positive, right? It's more than 0. So if we go back to our equation, where was it? Yep, it's here. Okay, we go back to the equation. We know that the change in volume is expansion coefficient times initial volume times the change in temperature. So this is just a variance of another way to rewrite this equation, right? So let's bring that there. The V is equal to this V naught delta T. And since we can see from the graph that this is positive, that means this must be positive when we increase the temperature, correct? And this is positive now because it's from 4 degrees to 5 degrees, so that's +1. Now, so this is obviously expand, but if we look at from 4 to 3 degrees, we realize that, hey, from 4 to 3 degrees, our B value, beta value is actually negative. So we do the sign accordingly. V is equal to this, V naught delta T, right? This is negative, but we also must be careful because our delta T represents a change from 4 degrees to 3 degrees. So this is also negative. So a negative multiplied by negative, this is going to be positive. So that's why this is expand. Okay, so this for part A. For part B, let's look at it. The temperature of water at 11 degrees is raised by 1 degree, the volume changes. Yeah, no shit. At approximately what initial temperature, T, will the volume of water change by twice as much? When raised by 1 degree C. Wow, what does that mean? Okay, so let's go back to this one and we see. Oh, okay. So we have this formula, right? 1 plus V naught. Sorry, V naught. That's delta T. Get rid of that. We have this formula, right? Just to confirm is correct. And they are asking for the temperature, initial temperature delta T, where the volume of water will change by twice as much. That means that V over V naught is going to be 2, right? Change by twice as much. When raised by, oh no, my bad. Okay, so change by twice as much. So that means that we need to find the original change in volume at 11 degrees C. So let me remove this. Okay, so at 11 degrees C, like this, erased by like this, we acceleration, we know that this is about 1.1, right? So the change in, okay, so we use the formula. Okay, we use this formula, I think it's better. And then we find the volume change. So the delta V is going to be 1.1 V naught 1. So that's our delta V. Now we're looking for the case where the temperature will change by twice as much. So our delta V prime is equal to 2 delta V. That gives us 2.2 V naught. We sum this in the equation, 2.2 V naught is equals to find where beta is going to be equal to 2.2. So we look at where beta is equal to 2.2. I think it's here. 2.6. Yep. Then we draw this. Then we go down. Then we realize that in order for the temperature change to be twice as much as the increase from 11 to 12 degrees, we need to increase from about 21 to 22 degrees.
The answer is 19 degrees.
19.
Yeah.
Wow. Why is it 19? Temperature. Okay, I got a feeling it's 19 because the difference in. Okay, let's see. Oh yeah, correct. My bad. Okay, yeah. So it's not 1.1, it's 1.01, right? The original one over here. 1. Then if we multiply that by 2 is 2.02. So we're looking for the temperature where beta is 2.02. So 2.02 is about here. This is 2.2. So if we draw that down, yeah, you're right. Should be 90. Yes, multiply beta. Just find temperature where beta is twice of beta 11. Yes, that's right.
So basically just multiply by 2 lah, the beta. Where 11 is at 1.1, then where beta is 2.2, which is double of the beta, that's the temperature for the. That's what they're asking for, right?
Correct. Because the temperature, the change in temperature is the same, 1 degree C and 1 degree C. Okay.
I don't understand that, but I think I know how to do lah.
Alamak. Okay, no. Okay.
Like because I'm in my mind, I'm trying to think like 1 degree, how can it go up 2 times of the coefficient?
1
Is
degree.
that the understanding of the? You
okay.
know what I mean? Like how can the volume change twice just by 1 degree?
Understand. No, the volume change is not twice. The volume change is twice that volume change at 11 to 12. So we got 11 to 12, right? Then we have a corresponding volume change. Then they ask you from what temperature, T to T plus 1, we get this volume change of 2 times that. Does this make sense? They're asking for what is the T where this happens. So the reason why you cannot just blindly multiply by the beta by 2 is you must understand. So what Dr. Ho can try to do, if he reference this question, right, then he want to tweak it a bit. He just say, this one change to 2. Then we are screwed already. Because we need to know the meaning behind this, how it relates to the beta. Okay, but in this case, I just quickly run through again. We have this formula, right? We have this formula that tells us that the change in volume is equals to this, right? Then we see that from 11 to 12, okay, let's sub in the values. 11 to 12, we have our delta V is equals to, okay, beta I read off. Read off, this one is about 1.1. This one we read already, 0.01. This 1. Correct? Then they tell you, what is this temperature? So our 2 delta V will be 2.02 times V naught times 1. Now, this is only true if they tell you that it was also raised by 1 degree C. But if they keep this question exactly as it is, then remove this, change to 2 or another value, then this one correspondingly will also need to change. Am I making sense?
Yeah, a bit like trying to understand a bit. So.
Okay, no worries. So I think it's interesting. No, it's useful to think of it this way. Put yourself in the shoes of Dr. Ho, right? He has that many questions that he can churn out. What can he do to existing questions that will make things harder for you? Or if you had to set the new question, how would you change it? Then you can start to think about how he will set questions as well, or how the examiner for the modules will set. Yeah, I said Dr. Ho. What did I say? Okay. Anyway, yeah. So if this is okay, if not okay, we can discuss it later lah. Well, let's run through the rest of the summary first, okay? All right. Wow, why die? No lah, won't die lah. Alamak. Okay. All right. Okay, so kinematics. Back to the summary. Kinematics. This is the first time I see this volume equation. Hey, your lecture notes must read, you know. I know you cannot just read, but you must understand the first time. So we just multiply 2 on both sides. Then the only thing that changes is beta since change temperature. Yes, Zheng Hong, you're right. They manipulate until that level. Oh yeah lah. So you need to have the understanding, not just blindly remember the formula lah. But the foundation is to know the formula, of course. Right? Like if you don't know the formula, then it's very hard for you to do this question if they change this lah, for example. You need to understand where the formula comes into play, how it is the data. Use the beta on the graph, find back the temperature. Yes, correct. Zheng Hong, you're right. Okay. Yeah. If that one unclear, maybe we run through later. Okay, but for now, let's run through kinematics. Okay, so the first thing that I want you all to know is the difference between instantaneous and average velocity, or acceleration, or displacement. But normally velocity, instantaneous versus average. Okay, so know the difference between these two. And at this juncture, I have an example question for you all. So let's say that I have a particle, and the particle adheres to a velocity like this. So this is very similar to your first few questions in the past year papers. Okay, so this basically means that the horizontal velocity at any time t is just represented by t. The vertical velocity at any time t is represented by 2t squared. Now, the question is, first one, find speed at t is equals to 3 seconds. And the second question is find average velocity across t is equals to 0 to t is equals to 5 seconds. Okay? So you can just roughly run through in your mind. I don't need to actually work it out. But I want to point out a warning that when you read the question, the word speed is important and the word velocity and average is important. Okay, so let's run through the two questions. Okay, so the first one, they asked us to find speed at t is equals to 3 seconds. So this is very easy, right? So we just say that at time t is equals to 3, we just sub in that. The velocity is going to be 3i plus 2 times 9 18 j, right? And we know that speed is not a vector, it's just a magnitude. So our speed is just the magnitude of this vector, t squared. Okay, so this speed. Now, the second one is a bit more tricky. The second one asks us to find average velocity from t is equals to 0 to t is equals to 5 seconds. The first thing we need to find is the total displacement, because we know the average is the total divided by the time it takes to travel, right? Total displacement over time it takes to travel. So let's find that. And also, we recall that displacement is related to velocity like this, right? I hope this is not new to you. I think it's one of the first few equations in your lecture slides. So I don't think anyone would miss that. So this one basically just says that if I have a velocity graph, say velocity be like that, the total displacement is basically the area under the graph. The mathematical understanding is the same as this. Okay. So you're taking math, right? So you should know how to do integrals. So the displacement is just half t squared plus 2 over 3 t cubed. Okay, is this clear to you all first? Because I understand people might get a bit scared when they see like math formulas. Everyone okay with how I get the displacement equation? Or this I lah, of course. Okay, so I assume it's okay, yeah. So displacement is just the integral of the velocity lah. Okay, then we just need to sub in from t is equals to 0 to t is equals to 5. So t is equals to 0, of course, displacement will be 0, right? T is equals to 5, we just write 5 squared, so that's 25. 25 divided by 2 is 12.5 I plus 5 cubed is 125. 125 divided by 3 is 250 over 3. 250 over 3j. Okay, so this is our displacement from t is equals to 0 to t is equals to 5. Then last thing we need to do, average velocity is just the total displacement or the total distance traveled divided by the time it took to travel. So you just divide this by 5. So that will give us 2.5i plus 50 over 3. Okay, so if you can understand this, if you can follow along, the first part of kinematics should be no problem. Okay, is everyone okay? Are you all still alive? Has there been a zombie plague that's rapidly diminishing the population and I'm trapped unaware? No? Okay, you all good? There are 2 questions regard to kinematic on Telegram. Oh, okay, let me take a look. Oh, the 8th one, is it? The velocity. Okay, I will cover that after we introduce the 4 main equations. Okay, yeah, so let's quickly talk about the 4 main equations. So the big 4 in kinematic, just as a quick recap lah, you should know. V squared is equals to u squared plus 2as. The second one, v is equals to u plus at. Okay, the third one, displacement is ut plus half at squared. Last one, which we don't really use often, but good to know, is s equals to u plus v over 2t. Okay, remember that all of this, the fundamental assumption is the acceleration is constant. So remember the assumption, acceleration is constant. Okay, yeah, let's take a look at any questions you all have. So Telegram looks like there's one kinematics question. Okay, let's take a look at this. Oh, so just this one. Hey, how come this is open? Okay, so we have this question. I think that I need to do the whole question. Yeah, can you all send me the whole question? Because this just looks like it's part 5. Okay, so while waiting, let's okay, I see the question. Okay, thank you to whoever sent that Telegram. Let me move to that question. Yes, okay. Let's see. Copy this. New paste. Okay, let's look at this. You're on the roof of this building, H equals to 50 meters above the ground. This professor who is 1.7 meters tall, walking briskly on cos split of E. Something here. You drop an egg on top of building such that your land on professor said, wow, okay. What balls? Which is the base on 20-meter building. At the moment you release the egg, you hear a toy gun shot fired from the roof, top of another 20-meter building. So over here, 1.8 meters away, okay. So remember, that's the intent of the shot. It's the instant egg that you drop. Okay, interesting. Wow. Okay, yep. So let's do this together. Okay, by any chance, does anyone have the answer? Is it 22 meters per second? Not sure. Okay, nice. All right. Okay, so if that's the case, then I can run through. Okay, so this is a very interesting question. So anyone needs me to run through the first? Okay lah, maybe I just run through all the parts lah. Okay. I can't show the questions all in this slide, so please refer to the Telegram picture when we are talking about the question. Okay, so let's start with part 1. So the context is you're on this 50 meters height. Your physics professor is 1.7 meters tall, constantly blah blah blah. You drop an egg, and you intend for this egg to hit the professor's head when he is underneath the building. Okay, so this will become key in part 5. But at the moment you release the egg, you hear a toy gun shot from here. Velocity is 50 meters per second, an angle of 40, and we know this distance is 5.8. Then they ask you, how much time is taken by the plastic bullet to reach the 50-meter building? So this one is very easy, right? This one we just need to find the horizontal velocity component of the bullet, and that is just 50 multiplied by cosine 40. So that's the horizontal component of the bullet, and of course the time taken is just the distance it needs to travel over the velocity. So it's just the distance divided by the horizontal velocity, 38.3. So this gives us 0.935 seconds left. So this is the time it takes for the bullet to fly from here and hit the egg over there. Okay, so question 2, let me open Telegram as well. I can see the question. Question 2 asks us, how high above ground does the plastic bullet hit? Okay, so I think this is fairly easy as well. We just need to recall the S equals ut plus half at squared. And we know that the displacement, the vertical displacement of the bullet is going to be its initial vertical velocity multiplied by time minus half gt squared. So I know it's minus because of course gravity will pull it downwards, but I'm letting the displacement upwards be positive. Okay, so that's why we have a minus here. And then when we solve this, we find that the distance sy is 25.7. So this 25.7 is relative to the 20-meter building lah. So of course we need to add the 20 meters. So you hit the egg at 45.71.
Can I just ask how you get 4.23? Because when I type into my calculator, I get I didn't get 4.23. I got 4 point something, but not 4.23, like 4.56.
Oh, it's not 4.23, sorry, it's 4.28.
Oh,
Yeah.
so it's like minus half times 9.81 times 35.8 over 38.3, is it?
Yes, square. Remember the square. Huh? Remember it's half 80 square.
Oh, right. Okay, thank you.
Okay. Okay, nice. So is everyone okay with part 1 and part 2 thus far? All good? Okay, nice. Okay, let me go back to Telegram. So Telegram, not Telegram. So part 3 asks us to show that the egg will be at the same height. So we know that this bullet is going to be a height of 45.71 meters. Then we just, after 0.935 seconds, right? So we just write the same distance formula for the egg. It's just minus half gt squared. So this SA is going to be with respect to the 50-meter building. So that will give us minus 4.23 meters with respect to 50 meters. So it's 50 minus 4.23. Then realize that, hey, we get 45.71 meters. So that's the same actually as the bullet, the vertical height of the bullet after 0.935 seconds. So that's why we can prove that the y coordinate is going to be the same and the x coordinate is going to be the same as well. So it's definitely going to hit it. Okay, then part 4 asks us if the velocity of the bullet is larger and maintained at 40 degrees, then it will be greater height. Okay, so that's because the time taken to traverse 35.8 meters is going to be less. So the time where the bullet will hit the egg is going to be less. So that means that the egg is going to fall a shorter distance. Okay, so I hope this is quite clear. Okay, so part 5 might be the one that's a bit tricky. So they tell you that, let me pull up the question. Oh, what's the question? Telegram. Okay. Okay, so they tell you that you have another egg at hand, and then you throw it vertically downwards with initial velocity VI, 0.6 seconds after the first egg was hit by the plastic bullet. And then the second egg hits the professor's head. Now, what people, I think what a lot of students might miss in this question is the how far away the professor is when you throw the egg, right? Because that is going to, of course, affect how much you must throw the egg down. Remember that in the start of this question, they tell you that you plan for the first egg that you throw, to 刚刚好, to just nice hit the professor's head. Okay, so in order for that to happen, in your first case scenario, if you intended for it to hit the professor's head, then you know that can I write this? Where did I write this? You know that initially, right, half gt square is equals to 48.3. So this is the first case scenario, right? First case scenario, we never threw the egg down, but we intended for it to hit. And if you timed it properly, your t, the total flight time, should have been where did I write? Oh my goodness, it's so messy. Sorry, give me a moment. 48.3 divided by 0.5 divided by 9.1. Yeah, your total flight time would actually be 3.14 for the first egg. And if you time it such that your first egg will hit the professor after 3.14 seconds, that means that at the time of your release, the professor must have been 3.14 times 2 meters away from the base of the building. Correct? Because you know that in order for him to be just nice under your egg, when your egg hits him, he must be 3.14 times 2 meters away, right? Because he moves forward at 2 meters per second, then he'll just nice hit the egg. Is this clear? So from this, we can find the initial horizontal position, how far he is away from the building. Okay, is this clear? Is that anyone? So we can find how far is he away based on the context in the question. Is that clear? Are you still following me? Okay, thank you, Keith. The rest? Okay, can so once you use that to determine the horizontal distance, then you can find the rest very easily already. The rest is just the normal equations and all that. Okay, all good with this question? All good, all good. Yes, Young-hoon. What is bugging you for part 5?
For the part 5, can I just use the VF equals to V0 plus AT squares?
VF is equals to V0 plus AT. Huh?
Yeah.
VF equals V0 plus AT, no square, right?
Oh, yeah, right.
Where do you want to use that?
For the last part. So because I already have my time, I have acceleration, and my VF is supposed to be 0, right? Because it hits the person, it going to be 0.
No, cannot. Because, okay, remember, when it hits the person's head, it decelerates on Dr. Ho's head, right? That means that there's acceleration acting, there's a force acting on this. Means acceleration is not constant already. Remember, when we use our big 4 kinematic equation, we assume the acceleration is constant.
Okay, so but when it hits the head, it's gonna be zero final velocity, right?
Yes, but we cannot use that equation to know what is t. Because the acceleration changes, right? Just before, so I draw lovely Dr. Ho's head over here. Just before it hits the head, our acceleration is 9.81 downwards, right? When it hits the head, the head is going to exert a force upwards. And that means that it is going to accelerate upwards. The egg is going to accelerate upwards, assuming it doesn't break now, of course. That means that our acceleration is no longer constant. And we recall that this big 4 equation, acceleration must be constant for this to hold true. Okay. So the way to solve this is, where was it? Yes, correct. Find the time that the egg must travel 48.3 meters, and then find the initial velocity from there. So once we know his displacement, how far away from the building he is, we can tell how much more longer is he going to take to be just under the egg. Then that time you use to sub into vi is equals to vit, sorry, that's half a t squared. Sub in the time. And then we know that this is 48.3, then we can find the vi.
Wait, the time will be 1.535, is it? Oh no, sorry, it will be 3 point something minus 1.535.
Yeah, I think so.
Okay, thank you.
Yeah, I think it's 1.605. Yeah, sorry, my screen very messy. That should be the time. What do you mean when you say cos the solution they minus 0.933 also? Why must 0.933 where? Oh, this one is it? Why must minus this? Because that's the time after you release the first egg, but they tell you 0.6 is the time after you realize that your egg has been pierced by the bullet, has been hit by the bullet, right? But in addition to that, we also wasted time, the 0.935 seconds where it flew downwards and it got hit by the first bullet. Okay. Okay, if you're finding this a bit confusing, I encourage you to. Okay, nice. Very good. Yeah. So is it okay if I move on?
Can, just that in the solution, right? They provided a very weird formula. T equals to square root 2 h minus the height, the 48.3 minus the height of the prof. I mean 50 minus the height of the prof divided by g. Is that just applying the formula?
Yeah, that's just the same as this, right? It's the same formula as this.
Yeah.
So
Okay.
that part just calculates the time it takes, the initial time. Your first case scenario, assume that your first one actually hit the dwarf.
Oh, okay. Thank you.
Okay. So we have to move on. We must move on. Before that, let me check. Let me charge my computer. Okay, yeah, I hope everything is still okay. Your brain is still working. Okay, so we have one more quick thing to do. That's forces. And for forces, let me do the summary stuff. For forces, it's actually quite simple. Just remember that you need to you need to draw the free body diagram first and decompose the forces which align to the acceleration. Okay, what do I mean by that? So let me give an example. Okay, let's say I have a slope. It's a very common scenario, right? I have a slope, and then I have a block of mass m, and I tell you that the block is accelerating downwards the slope. Okay, so whenever you see this kind of questions, the first thing you need to draw is your free body diagram. Free body diagram, of course, we have our mg going downwards. We have our normal contact force in this direction. We also have a frictional force moving backwards. Correct? Frictional force. And we know that this is going to result in the block accelerating downwards. Okay. So usually the first thing that we need to do is to find the direction with no acceleration. Find direction with no acceleration. And we realize that in this case, along the normal contact force direction, there's no acceleration, right? It's only accelerating along the plane. So that means that F in this direction is equals to 0. The direction is equals to 0. And therefore, Fn is equals to mg. Okay, let's say this is inclined at theta, mg cosine theta. Then the next thing we need to do is to find other forces. Find other forces. So in this case, we know that our frictional force is coefficient multiplied by normal contact force. And if we are given this, which we always are, we can find this force, Fk. And the last thing we need to do is to relate the forces to the acceleration. Relate forces to acceleration. And in this scenario, once we know Fk, we know that mg sine theta. So that's the downward component of this, right? The downward component of this. Mg sine theta minus Fk is equals to mass times acceleration. So this is rough. This is a quick summary on what we need to do, or how you should approach the question, any forces question. Okay, so I understand that there was a forces question on Telegram. Let's take a look at it very quickly. Okay, so let's read the question now. So I'm not going to give you time to do this because, yeah, we can run through this, and this was on Telegram already. So to tell you that there are three blocks. M1 is 15, M2 is 8 kg, M3 is 6 kg. Then they tell you that there's an inclined angle 37 degrees and the frictional coefficient is 0.4. Then they tell you that this is moving downwards. Okay. So the first part, they ask you to draw the forces. So I think it should be quite easy, right? Let me just move this away. So we look at the first one. Let me zoom in a bit. We look at the first one. We know that definitely tensional force, right? Tensional force is going to put this here. We know that there's a weight, so it's mg. We know that there's a normal contact force, so that's Fn. We know that there's a friction as a result of normal contact force, so that's Fk. Okay. Now for the second one, the tire is frictionless, so there's no friction. Very strange, right? I don't know why the second one no friction, but here got friction. The only forces are the tension force T2, tension force here T1, the mass mg. So it's a normal contact force Fn. Okay. Now the last one you see they purposely leave a gap here. There's no friction, so it's pretty straightforward. It's just mg, and the tension force is just T2. Okay. Then they ask you, by applying the Newton's second law for the blocks, calculate acceleration for the system and the tension T1 in the string. And the only information we are given are the mass of the blocks. Okay, so let's try to use our strategy for the first one. Okay, so remember our strategy, the first thing that we need to do is to find the forces which don't result in any acceleration. And we know that acceleration is going to be along the plane, right? So we'll consider the forces perpendicular to that, consider forces in this direction. Okay, so let's look at the forces. Fn, this must be equal and opposite to the component of weight. Is it sine? No, sorry, it's cosine. Cosine 37. Then we can find Fn. Then once we find Fn, remember our second step is to identify the other forces. So from Fn, we can identify Fk. That's stress friction coefficient, which is 0.4, like 0.4 times Fn. Okay. Then our last thing we need to do is to relate the forces to the direction of acceleration. So we just let the acceleration of this block be A. Let the acceleration of all the blocks actually be A, because the string is all times length, so all the blocks have the same acceleration. Okay. String is taut means it is constantly pulling the force is constant throughout time. So T1 doesn't change as it moves. T2 doesn't change as it moves. So this whole thing accelerates together. Okay, so we let the acceleration be A. Then, of course, we just decompose the forces. We look at the forces. Okay, so we realize that this thing pulling downwards, we have mg sine 37 degrees minus the frictional force which we found earlier. So this is m1. m1 was 15, right? 15a. Now we look at m2. So m2 we know that it's just t1. Oh, sorry, this one minus. Forget to minus t1. Right, because we still have t1 pulling over here. Yeah, I hope you all caught that before I did. Okay, so for the second one, we know that if A is accelerating, sorry, if M1 is accelerating downwards, M2 must be accelerating to the left. So we let T1 be greater than T2. So T1 minus T2 must be equals to the weight of M2, which is 8 kg, multiplied by acceleration, right? Because all of them share the same acceleration. Then we can do the same for M3. So M3 is MT2 minus M3, I think is 6 kg. Right? Yeah, 6g is equals to 6a. Okay, so at this point in time, we have three equations. 1, 2, 3. We have three unknowns, T1, T2, and A. Then three equations, three unknowns, we can solve this very easily. Shall we take the direction of the motion to be positive when equating the forces? As long as you're consistent. So if I don't know the direction of motion, right, I can assume is okay. So I assume that acceleration is in this direction, right? So in order for acceleration to truly be in this direction, I know that mg, this component must be greater than t1. That's why I put mg minus t1. Correspondingly, I can also assume that my initial acceleration is going towards this way. If that was the case, my equation is going to be t1 minus mg sine 37. So as long as you're consistent, it's okay. Okay, everyone good with this? Yes? Okay, nice. Yeah, so I think the last thing I want to cover is circular motion because I heard that it is within the quiz syllabus. Yeah, so just a gentle reminder that we have this thing called centripetal acceleration or centrifugal acceleration. It's given by m omega square r or mv square over r. We also know that this equation holds true as well as this equation. So this one just means that the distance travels, let's say from here to here. So this s is the same as the radius times this angle. I change this is the radius, right? Just a gentle note that this theta should be in radians. Okay, so that is centrifugal acceleration. There's another type of force that can result in a change of circular motion, and that is your tangential acceleration or tangential force. I don't think the formula for omega, you mean omega equals to v over r, is it? Yeah, I don't think this is given. You need to know this. So yeah, just bear this in mind. Not too sure. Yeah, so there are two types of forces as it moves. One is into the center of acceleration. The other one is tangential. So let's say I'm swinging this already, then I got a rocket thruster over here. Then it moves up. Then this is going to result in a tangential force, which is going to result in tangential acceleration. So tangential acceleration is just your angular acceleration multiplied by r. So don't be confused over this two. Okay, yeah, so just something for you to note. Okay, unlearn to centripetal, then yeah, then that's good. Means this thing probably won't come out. Okay, are we good? That's all I have for y'all actually. Yes. Is there anything else? Yeah, you can like unmute. Do we need to know how to convert RPM to some? Yes, of course. To radians per second, right? RPM to radians per second. But I think that is fairly trivial, right? So we know that one rotation is one complete round around the circle. And one round around the circle is how many radians? What is your S? The S is the displacement, is the distance traveled. So this is this S. Okay, so S is equals to R theta. And yes, correct. So one rotation is 2 pi radians. So if we know that, if I tell you an engine runs at say 500 RPM, right? If an engine that runs 500 RPM, this is equals to how many radians? Yes, correct. 500 times 2 pi, so it's just 1000 pi. 1000 pi radians per minute. Then to convert to radians per second, yep, Kenyang is right. Just divide by 60. 1000 pi over 60 radians per second. So this RPM to radians per second. So if you need the formula, I think RPM is equals to 2 pi over 60 radians per second. Okay. May I know for the linear velocity is equals? Oh, okay. So if you want to find the linear velocity given a particular angular velocity, right? Is that your question? Okay, if that's the case, just need to remember this equation. V is equals to omega. Because this velocity is, remember, in a circular motion, the only component of velocity is the tangential velocity. So they'll be here, then if it's here, it'll be like this direction, tangent to the circle. It's here, it'll be like here. Okay.
Hi, can I ask about the submarine question? Do you remember the 2018 submarine question?
Okay. Yeah. Okay. Maybe we leave that at the end.
Oh, okay, no problem.
If anyone has any questions about anything else? Okay. Any other question? Otherwise, we will move to the summary question.
Yeah, hello, hi.
Yes. Hello.
Yeah, hi. It's like I can't still like determine the sign convention for the kinematics.
The sign convention, is it?
Yeah.
Okay, the easiest way I can know to tell you about the sign convention is if we take a case like this. So if you're standing here and then you throw a ball up, let's say it's 10 meters per second at an angle of 30 degrees. Okay, then I ask you, I think this might be useful. So this is the equation that we are given, right? ut plus half at squared. Then I ask you to find the vertical displacement. The sign convention is always set by u. So in this case, I'm going to let upwards be positive y. Okay, so I look at the formula. I know that the initial velocity is going to be aligned with my direction. So it's 10 sine 30 t. And I know that gravity is going to pull it down, which is opposite to my initial coordinate, what I assume is positive. So that means that they should be half a minus g, because this will pull it down, t squared.
Okay, so it's like because I set my arrow as upwards.
Correct.
Okay, thank you.
If you want, you can also set this as positive. Now, if I set this as positive, then my s is going to start with negative 10 sine 30 t plus half gt squared. Then my distance will be measured downwards.
Okay, thank you.
Okay, can do part C for the roof of the house question on Telegram. Okay, let me take a look. House question. Telegram. Okay, so let me copy that question over. Okay, so let's see. As shown in the diagram, row house tilted at an angle of 37 degrees above the horizon. 7. When it rains, the water typically slides off the edge of the roof. Okay, Jonathan. So maybe for the sake of everyone, we run through the questions now. Okay, so it says that angle 37 degrees. So this 37. When it rains, it typically slack off at a velocity of 1.2 meters per second. So initial V is 1.2 meters per second. The edge of the roof is 3 meters above the ground. Then they ask you to find the horizontal distance where the rainwater is expected to land. So for this, we just have to find what is the time it takes for the rain to move from the roof till it hits the ground. Okay, so if we do that, we need to use this equation, ut plus half at squared, where s is 3, because we are told that the roof is 3 meters above the ground. U is given as 1.2 sine 37, So that's our vertical component of the velocity as it slides off the roof, and acceleration is half gt squared. Okay, so in this case, I let this be positive because I let the downwards direction be positive, right? 3 meters is going downwards, 1.2 is going downwards, and gravity is pulling downwards. So that's why I have it to be positive. Then from this, I can find the time. And after finding the time, I know the horizontal component is 1.2 cosine 37. I can just take the horizontal velocity multiplied by the time. That's going to give me my displacement. Okay, so that's for part 1. Then for part 2, I know that the horizontal displacement, so horizontal velocity component is not going to change because there's no acceleration. So the Vx is the same. Vx is still 1.2 cosine 37. But for Vy is not going to be the same because Vy is going to be put down by gravity. And I know that I have this lovely equation, right? The final velocity is the initial velocity plus 2 times acceleration times displacement, correct? And I know this. I know acceleration is g. I know this displacement is 3 meters. I can find this very easily. So this is my final Vy. I have my Vx, which is initial. Then I can find the vector form. Okay, then for part C, they tell us that it's observed that the rain lands at 0.9 meters. So I know that if it has to land, okay, if it lands at 0.9 meters, then it fits this formula, right? So 0.9 meters is equal to the x component. Okay, so I let the velocity be v in this case. In the last case, the velocity be v. So the horizontal component is still v cosine 37 because the angle of the roof is not going to change, and then multiply this by t. So that's the displacement, right, in the x direction. I know that in the y direction, the displacement is still going to be the same, which 3 meters. So 3 is equal to v sine 37 or ut plus half at squared, so half gt squared. So I have two equations. I have two unknowns, t as well as v. I can solve it very easily. What do you mean when you ask for the vector? Is it always vf or v naught?
Like example on the question B, right? Since I know Vx is always constant from not to Vf, so I don't need to concern. But then for Vf, sometimes I'm not too sure should I use the final velocity as the vector itself or the V naught itself
Uh,
to get the
okay.
or the I or the J.
For J, they ask us to find the vector just before it hits the ground, right? When it hits the ground, so it's definitely going to be VF. Just before it hits the ground, so it's the initial velocity in the y direction after it's input by gravity. Okay, are we good? Okay, no problem. Okay. Can we call this a night? Is everyone okay? Is everyone feeling good for the
Quick,
quiz?
quick
Yes.
submarine question.
Oh yes, okay. Oh yes, thanks for reminding me. Okay. let's put up the summary question. Okay, so I'm just going to run through it very quickly because we have done this. Where is the summary question, my gosh? Oh yes, found it.
I remember what you taught, but then I tried to do it like using my own method, but I just didn't know like which part of my working is like wrong.
If that's the case, I'm willing to wager it's probably a careless conceptual mistake somewhere.
As in, I didn't use what you taught.
Mhm.
Okay, yeah, the first diagram, right, tells us that the mass of the submarine is 1,130 tons. And then the second diagram, right, tells us that the mass of the submarine together with 20% of the ballast is 1,200 tons. So I subtracted it to get 20% of the mass of the ballast, which is 70 tons. And then I found 100% of the ballast, which is 350 tons. Then after that, I went to get the total mass of the submarine and the ballast at 100%, which will be at 1,480 tons, which is 148 million thousand, I don't know, kg. Then after that, then I tried to find the buoyant force, which is taken by the density of the fluid, the density of seawater, which is 1,020, multiplied by the volume of the seawater, which I believe will be the same as the volume of the submarine. So in order to get
wait. How come? Okay, repeat the last sentence.
sure, I tried to get the buoyant force, which is I took the density of the seawater multiplied by the volume of the total seawater that it displays, which I believe is should be equals to the volume of the submarine.
Yep.
Then I multiplied that. To get the volume, I took the total mass of the seawater divided by the density of the seawater.
Wait, to get the volume?
To
you
get the
took
volume, I took the mass of the seawater, which is 350 tons, because 100% of the ballast is 350 tons, multiplied
No,
by.
no. The ballast is when you fill the ballast, the volume doesn't inflate.
Oh.
It doesn't change. A ballast is a rigid structure inside a submarine.
Oh, okay. Oh yeah, oh. So I can't do this method, is it?
Yes, correct. So the
Also-
volume remains the same from here to here.
Also, my entire method is wrong. I need to use the U minus mg that thing.
No, your method from here to here is correct. So you find the initial mass of this, very good. You find the capacity of this as well as the mass when it reaches 100%. That's correct. But your mistake comes in here to here. When you add in water, the volume doesn't change.
Then how should I calculate my buoyant
You
force?
already have the buoyant force from here. Because the volume doesn't change from here to here, right?
Yeah.
The volume displaced doesn't change, right? So your
Yes.
buoyant force is going to be the same as just nice when it totally submerged.
Oh. Oh yeah. Oh. Oh. Okay. Can. Thank you.
No problem. Okay. Let's see. Can I just ask for a typical stratospheric balloon and payload? Do we neglect the upthrust of the payload in calculus? Oh yes. Yeah. I think in most cases you can assume that. So from what I'm understanding, you're asking if like we have a hot air balloon and it's carrying a payload, then they tell you the volume of the hot air balloon, right? Then they say they ask you to calculate the upthrust. We don't care what is the volume displaced by the payload because we usually assume it's very small. I think in most cases you can assume that. But in the final exam, just write the assumption line, doesn't hurt. Just say assume payload has negligible volume displaced compared to balloon. Yeah, just state clearly the assumptions. Oh, COVID.
Final thing, 1,200 tons is the mass only. I still need to multiply by 9.81 to get the
Yes.
buoyant force. Okay, thank you.
Correct. Okay, anything else? Are we good? Are we ready to get full marks for the quiz? No, my goodness, why? Hey, then all my effort for the last many hours and Wednesday also. Why you all like that? Ayo, don't disappoint me. My poor palpitating heart can't handle the disappointment. He confirm come out some level 4, level 5 question. I don't know. No, I don't know. I thought normally quiz should be easier. Okay, but full disclaimer, I didn't take physics A. Actually, I didn't take physics. So I don't know. Is Dr. Ho. Yeah, but Dr. Ho is a human. And what makes you... Okay, I should stop recording this before I say I'm sorry. Yes, okay. On a serious note, is everyone okay? My worry is if I can understand the question. Yeah, so I guess my only tip for that is to calm down. Don't panic. Because you understand things better if you're not like stressed or worried. it's normal to be anxious, of course, but just take the time to read the question. Just breathe in, breathe out. Later he play with the English test, my understanding. Yes, okay, I agree that that's the case. Case in point, even the egg dropping one, right? It takes a bit of English to understand that his initial one, he already intend to hit the vessel. Then that's a trick lah, to use that to find the horizontal displacement. Yeah, I don't know. I think apart from improving English, which is going to take super long, the next best thing is to try to know a variety of questions law. Just do as many questions as you can. Know what kind of tricks you can pull. Yeah. But for quiz, I don't think he has a lot of time to play with English, I hope. And don't worry, even if you can't do level 4, level 5, if the rest of the foundation question you can do, then overall you should be able to do well lah. If all the concepts that we talked about just now during the summary, if you understand that, should be okay. Don't worry. How would you gauge? I don't know how I gauge. I just do as many questions. Okay, I think for me it would be if I am very familiar with tutorial questions, and if I pull any random past year paper question, I am able to do that topic. More than 50% of students at SC we take the test. Are you sure or not? Get from where? Wait, okay, but MAE supposed to be different from SC, right? Come on, you all here from MAE, right? Maybe their strength is in programming. It's not solving physics. Come on, have some pride. Drop egg without internet. Alamak. Okay. And if you are going to keep plotting how to assault him, I don't want to be a part of it. I want to graduate. Don't want to be locked up somewhere. Okay, yeah. Anything else before we call it a night and I can go home? Yay! Yeah. By the way, just to need to thank the people who are in the room and have been patient with me talking out loud. I don't even know why I said that. Yeah. Okay, but serious not? Is everyone okay?
On the RPM, right? You put it 2 pi over 60. So
Yes.
equivalent to me that the 60 mean is the T in it. The like 2 pi.
Okay, RPM stands for rotations per minute, right?
Yeah.
And at the end of the day, we want it to be radians per second because most of our equations, the units is radians per second, right? So the formula is just 2 pi over 60, no? 2 pi over 60 of A RPM is B radians per second.
So linear velocity is your omega r, right? So omega is a 2 pi over t.
Linear velocity, sorry, say again?
Linear velocity, the formula is 2 pi r over t, right? Or
2 pi r over...
yeah, which is omega is 2 pi t, right? 2 pi over t.
2 pi
over t.
Over... Wait, what?
T.
Okay, no problem, Keith. Yeah, sorry. How do you get omega is 2 pi over... Oh, so T is the period lah. T is the time it takes to go one revolution, right?
I'm not too sure. Because there's this question on our lecture, then some sort of copy like the omega is 2 pi over t, then the r is the radius.
Okay, yes, r is definitely the radius of rotation. And if this t is the time period it takes to complete one revolution. So I tell you that one revolution takes 1 second. Then yes, this t is just 1. Then omega, it is in fact 2 pi radians per second. Yeah, no problem, Ken Yang. Have a good rest. You okay?
Yeah, should.
T is the period, the time to complete one revolution.
So, so example, if I have 2,500 RPM, my omega gonna be 2,500 times 2 pi over 60.
Yes, correct. Correct. Yeah, that's right. Okay, yes, that's why I'm in school, as it turns out. Okay, I think we can stop the recording first. Is there a makeup